Hello everyone, I am Nidhi Yadav and I am from Test Automation Competency. Today I am here to deliver a session on the topic Optimizing Test Execution, Heuristic Algorithm for Self-Healing. Before we dive deep into the topic, let's first go through the knowledge etiquettes, which are as follows. First is punctuality. We need to join the session 5 minutes prior to the session so that the presenter can start and conclude on time. Secondly, feedback. Try to submit a constructive feedback for all the sessions as it is very much helpful for the presenter. Thirdly, silent mode. Keep your devices in silent mode and also feel free to move out of the session in case you have an urgent call to attend. Fourth and last, avoid disturbances. Try to avoid chit chat during the session and maintain discipline. The agenda for today's session is as follows. Firstly, we'll go through the introduction where we'll look to the challenges of traditional test execution, followed by the importance of optimized test execution. Secondly, we'll go through the self-healing concept, like what self-healing is and how that whole process works. Thirdly, we'll see about heuristic algorithm, majorly for self-healing, like what are heuristics and why we need to implement such algorithms to ensure self-healing test scripts, followed by the best practices which we should ensure to implement heuristic algorithms. Lastly, we'll look to certain heuristic algorithms which we can apply, such as adaptive locator recovery algorithm, LCS, meaning longest common subsequence algorithms, annotation based locator algorithm, and lastly, retry mechanisms. All this will be followed by a demo, and lastly, we'll end up the session with a QA session. So let's start with the introduction. Here comes the slide for the challenge of traditional test execution. So what is test execution? It's basically a process of running a test or an application using automation tools or frameworks in order to check the functionality, performance, efficiency, and the reliability, and to check that whether that application or software is meeting the user's requirement or not. But since we use traditional test execution methods, there are certain challenges which can lead to not a very optimized execution process. So the challenges are as follows. First is high maintenance efforts. So when we use traditional test execution methods, they require constant updates to the scripts, and those updates needs to be handled by the testers manually, which results in an increase in the resource utilization, and the time also taken is very much is increased. So traditional test execution results in the increase in the high maintenance efforts. Secondly is frequent test failures due to minor changes. Changes like updates to the user interface or the backend logic can cause the scripts to fail, and these failures will result in false positives and negatives, which will result in complicating the identification of the real issues. Third is time-consuming debugging processes. So test execution is, as we know, is a very much manual and complex, and also at the same time time consuming process. So QA teams, they basically spend a significant amount of time in analyzing the logs and reviewing the code, and all this process is very much time consuming, which might delay the providing of the feedback to the developers. Fourth and last is lack of adaptability. So the traditional execution methods which we use, they lack flexibility to adapt to the changes quickly to the dynamic elements whenever a website or an application is undergoing development or undergoing changes. So this results in an inability of our scripts or the application to adapt quickly to the changes of the application. So to overcome such challenges, we should implement optimized test execution. The importance of optimized test execution. First is enhanced efficiency. The optimized test execution ensures that test processes are streamlined, reducing the time and effort required to run the test. Means that when we run our test in an optimized manner, this will allow us to have frequent testing cycles and allow us to provide a faster feedback, which is a very important point for agile environments. Second is improved reliability. by minimizing the false positives and false negatives. False positives and negatives is basically false positive stands for like detecting the changes that have not been occurred, and negatives is the opposite of it, like to detect the changes which failing to detect the changes which have not been occurred. So if we implement optimized test execution, it will minimize this uncertain behavior, and also reliable testing will be ensured throughout the script. Third is better test coverage. Optimized execution will help us to get a broader and deeper test coverage, and will make us to ensure that entire application or every aspect of the application is being verified, reducing the risk of undetected bugs. Fourth is enhanced adaptability. It will allow the test scripts to adapt quickly to the changes in the application, ensuring that testing remains relevant and effective even as the application evolves. So if a script is adaptable, it will uh, adapt to the changes of the evolving application, and our scripts will run without any failure or without any stoppage during the runtime itself. Next comes understanding self-healing. Here's a brief overview of what self-healing is. So self-healing is basically the automation of test automation, recognizes changes in the system under test and automatically adapts the test execution during runtime so that the test remain functional. So self-healing is basically a feature or is a mechanism of framework which makes our framework adaptable to the changes, and it allows our scripts to run uh, without any breakage during the runtime itself. So this approach will help our scripts to heal themselves, to detect the changes which whatever changes have been occurred in the object properties, and will on the same and alongside it will also update those objects with the new attributes. So all this mechanism or self-healing process will enable or will increase the effectiveness of our testing procedures, because it will diminish the need of manual intervention, and also the resource utilization will also be minimized. There are certain commercial tools available in the market like Functionize, Apply Tools, Mabel, Testing, which we can use. And also there are certain open source tools like Test Project and Selenium that support self-healing, and which we can integrate in our projects to make our scripts with self-healing capabilities. Next comes how self-healing works. So self-healing, this is basically an end-to-end workflow of the self-healing mechanism. Firstly, the automations, whatever script we have written, it is executed normally till and it gets executed until and unless an object is not been found by that WebDriver. Then in second step, the self-healing mechanism gets triggered whenever an exceptions like no such element or element not found has been triggered. In third step, the with the help of certain AI algorithms, the the objects and their properties of the current DOM, they are extracted to store it as a backend, to store it as a base to compare it with the changing object and their properties. In the fourth step, with the help of certain AI algorithms, it could be any AI or ML algorithms we can use to implement self-healing. It compares the similarity scores between the changed object and its properties and the saved object and its properties, which was saved initially in the backend. And depending upon that similarity scores, it finds out the best locator which is best suited for that object, and attempts to run that scripts in same runtime using that healed locator. At the same time, this mechanism updates the broken locator with the new updated locator value in the object repository, so that when the script is run in future, it uses that updated locator instead of that broken one. So this was the overall process that how self-healing is actually functioning in our test script. Next comes the heuristic algorithm for self-healing. So before starting the slide, I want to ask you people that what do you people understand by heuristic algorithms or the word heuristic? If any one of you could answer.
Yes, Mustafa, you have raised your hand. I'm sorry, we can't hear you. No, Mr. Fizur, I'm sorry, we can't hear you. If you're speaking anything, I can see you unmute, but I can't hear you anything. Maybe you can type in the chat column.
Okay, so I'll continue with it. First,
Nidhi, Mr. Fizur has replied in the chat having previous knowledge or prior knowledge.
okay, yeah, it's correct. You are right, Mustafizur. That heuristics is basically heuristics are basically methods with which use shortcuts to find the solutions quickly. Like they do not rely on the classical methods. They depend on the previous experiences, or we can say previous practice, rather than just relying on the previous precise calculations. So these algorithms or these methods are also known as approximate algorithms, and they provide us a near perfect solution within a given time frame, or if you want a solution to faster solution when the classical methods fail to provide us that particular solution. So for that case, we switch from classical methods to heuristic algorithms. But now let's understand that why we need to use heuristic algorithm as compared to classical methods. So first is holistic approach. Heuristic algorithms, they follow an holistic approach, like meaning that they consider certain factors and scenarios which will help us to provide a more comprehensive identification of the issues, and also at the same time will provide us the idea that how we can resolve those issues. So heuristics, they follow this type of approach. Second is customization. Such types of algorithms can be customized uh, according to our needs, according to the application which is to be tested, and according to the context or the needs of the application. So this customization will help us to gain a tailored solution, which is not possible if we use the rigid self-healing tools available in the market. Third is flexible and adaptable. Since, as we read, that heuristic algorithms, they learn from past experiences, so they can improve over time according to the past information or the past learnings. This will help these algorithms to adapt quickly, and they also will help these algorithms to evolve over time. Fourth is efficiency. Heuristics, they offer a faster problem solutions than the classical method, because they, as we read, that they use shortcuts to find the solution, and they also provide a near end solutions to the problem in a given time frame. Next comes the best practices, which we need to make sure that these practices should be involved when we want to implement self-healing in our framework. So first is clearly define the scope of self-healing. uh, this point indicates that we need to focus on the types of failures which our self-healing mechanism or self-healing algorithm should majorly focus on. These failures could be due to the UI element changes, like the locator value gets changed, or they could be due to any data change, like any missing data value or unexpected data format, or it could be any related to failures related to test environment. So we need to focus, or we need to clearly define that uh, what type of failures need to be addressed by that heuristic algorithm of self-healing. Secondly, we have carefully design and test heuristic. We need to choose the right heuristic algorithm according to our application and the context in which we are going to test our application. Like, as we read the type of failures, for frequent changes of the UI, we can go with attribute proximity search algorithm, which is basically an algorithm where the element is where the self-healing takes place depending upon the element's position with respect to the other elements. Then if the scenario is very much complex, then we can use certain machine learning algorithms to implement self-healing. And if there are failures due to network issues, or you can say slow loading elements, then we can use retry mechanisms to rerun our failed test during the runtime itself. So These were the type of like how we can design our heuristic algorithms. Third is monitor and refine the self-healing behavior. It is very important to monitor the logs about the test execution, which was done during that using that heuristic algorithm, because that logs will provide us a wide range of information regarding the original locators which got failed, the healed locators like which were used in place of those locators, the what self-healing actions have been taken place, etc., etc. So all this monitoring of the logs will help us to refine and improve our heuristic algorithm for future usage. Fourth is start small and scale incrementally, meaning that we need to first implement our heuristic algorithm on a small project or a small test to ensure that it is working as expected, so that we can lower down the risk of failure in our bigger projects. So we need to start small and then gradually we can expand our scope of heuristic algorithm. Fifth is rollback mechanisms. In our heuristic algorithm, we should ensure that there are certain certain mechanism which can revert our self-healing behavior if if it is not working as expected. Like we can add an option of disable healing for certain test scripts, and which will for certain test scripts, and providing the original test script, we can take a backup of the original scripts to be used when our healing is not as expected. So these are the best practices. Now we'll go through the types of heuristic algorithms. First is adaptive locator recovery algorithm. It is a sophisticated heuristic approach designed to enhance the reliability and robustness of automated testing. So this algorithm basically uses three types of heuristics: search by visible text, search by neighboring elements, and search by regular expressions. Here's a flowchart uh, depicting the working of this algorithm. It will first start the process. This algorithm will first try to locate the element using the original locator. If it is a success, it will perform the action, whatever action we want that element was supposed to perform, like clicking or visibility, anything, and the test will end. But if that element is not found using the original locators, the algorithm comes into action. It first tries to locate the element using the visible text heuristic, where it will find the element according to the text which is displayed to the user. If found, then it will update the locator of the updated locator in the JSON file and will execute the script. If not, then it will move on to the neighboring element heuristic. In this type of heuristic, it will find the element based on the relationship between the elements in the DOM structure. If found, then again it will update the locator and continue test, else it will move on to the regular expression heuristic. In this regular expression heuristic, it will find out an alternate locator or find the element depending upon a certain pattern, like regular expression, based on its attribute, like ID, class, or name. And if that element is found, it will again update the locator in the JSON file and execute the script. And if not found, it will log an error message indicating that element was not found with any of these heuristics. Next comes the use cases of this algorithm. First is data-driven web applications. There are certain websites which are based upon which require database to store the data, and then they use those data to foster the functioning of that website. So this might cause the elements attributes to change according to the data which has been stored in database. So for this case, we can use the regular expression heuristic to locate our elements using the partially matching attributes. Second is responsive website design. Responsive website design means that a website is responsive to different screen sizes, uh, and different screen sizes, and it will help. It will allow the elements to rearrange themselves according to different screens, whether big or small. So for this case, we can use a neighboring element heuristic to target those elements according to the position in the DOM structure. Third is A/B testing. So A/B testing is basically a test type of testing where two versions of an application is presented to the user, and a comparison is made that which one is more reliable or which one is more efficient or providing more information. So for this testing, we can also use this algorithm, and to be more specific, we can use the visible text heuristic for this. where we can, for example, like we have buttons saying that start free trial on one page, like a part, and for B part we have a button saying begin your journey. So for this, for finding the element, we can use a visible test heuristic to find that if that element is being changed according to the visible text. Fourth and last is accessibility improvements. So there are certain websites with which add the area labels attributes to change this causes a change in the elements structure. So for this case, regular expression heuristics will be very much helpful to adapt to such changes and locate our broken elements. Next is longest common subsequence algorithm. So it identifies the longest subsequence that is common to all sequences in a set of sequences. So longest subsequence algorithm is basically a dynamic approach or dynamic technique where there are two sequences like A, B, C, D, and E, F, G, H, and among from these two sequences, we found out the best sequence. We found out a common sequence that is maintained and without maintaining the order of those elements in that sequence. So this algorithm is used as a this algorithm will be used as in an enhanced manner by considering the weight of various attributes like tag, ID, class, etc. So this algorithm, longest common subsequence algorithm, follows a tree comparing approach where it first gets the current DOM state, then searches the current state for the best subsequence, and then it generates a new locator to be used. So the very popular framework or tool which uses this algorithm is Selenium. Selenium uses an advanced version of longest common subsequence algorithm, including weights. So weights are assigned to the element to set the priority of the priority to the attributes, that which attribute will be taken into consideration first to find out the healed element. Selenium is can be used. It is very much popular for Selenium based tests. It will improve the stability, and Selenium it triggers whenever a no such element exception occurs. It triggers the LCS algorithm within it, and from the backend store where it stored the first run locators, it will compare the tree like current state and the stored state, and find out the best match of the locators which will be used in that in the broken locators place to heal that element and continue our test in the runtime. Third is the annotation based locator algorithm. This algorithm is capable of testing a website and restoring the locators in case they are broken. So for this algorithm, there are certain special attributes which are used, like previous ID, previous class, previous attribute, and previous value. These four attributes are used as a special attributes to locate the broken to locate an alternate locator for the broken elements. So the working of this algorithm goes as follows. First we have a list of locators or the elements consisting of the locator key and the value. Then with the help of get locator attribute, we can find out the attribute of those element, and with the help of get locator value, it iterates to the elements in the list and takes out the value of the locator. Then it finds the value of the node where it will execute the execute locator function, takes two parameter attribute and value. On executing this function, if the node value is null, is not null, then it will execute a test using this node value, whatever test we want to carry out. But if the value of a node is null, then it will go to find a new node value using the find new node function. The find new node function carries two parameters. One is attribute and one is value. This one is the original attribute and value stored in the list. So if our attribute is ID, then it will find the node value depending upon the previous ID, which is a special attribute, and value will be the same, and it will execute the find node function. But if it is attribute is class, it will use previous class. If attribute is previous if else if none of these, then it will move on to previous attribute, like whatever attribute will add onto that like name or and tag, and it will use that value. to find out the new node. Then if that new node is not null, it will return that its new node attribute and new node value by executing these get new node attribute function and get new node value function. And once the new node is found with the desired value and the attribute, it will restore that locator in the list. That is, it will update that original local locator with that new node value. And using that new node value and attribute, it will execute our test in the runtime itself. Next comes the use cases of this algorithm. First is cross-browser testing. So cross-browser testing means testing our application on different browsers. This will this causes our application to run with slight variations. So for this purpose, we can use annotation-based locator algorithm to find alternate locators when the primary locators gets failed in different browsers. Second is agile environments. In agile environment, we know that there are frequent UI changes, and this algorithm can help us to maintain the stability, because when an element's ID is changed, then the algorithm will attempt to find the new node or new value to for that element using the previous ID value. Third is parallel testing. Parallel testing means that testing of our application on different machines parallelly. So for this also, we can use this algorithm as a heuristic approach. This algorithm will help our test instance to find the correct elements which might appear differently in different machines during parallel execution. Fourth is single page application. So single page application is an application where all the UI elements are on the same page, and it does not redirect to the multiple pages and multiple tabs. So in single page application also, like they are made using the frameworks like React or Angular, and such applications, they cause our element IDs to be dynamic in nature. So for locating such elements, it might be a stressful task, and using this heuristic algorithm, we can find out an alternative locator for such dynamic elements in single page applications. Next comes the retry mechanisms. Retry mechanism is a mechanism which will automatically helps us to retry a failing test a limited number of times using interfaces like iRetry analyzer, or we can also use a rerun plugin in our test runner file. So retry mechanisms is basically used whenever there are failures due to network issues or there are temporary glitches. We can use a retry analyzer attribute in our test annotation as it is shown here. We will uh, use the retry analyzer attribute in the test annotation, and we'll create a class of named retry, which will implement the iRetry analyzer interface. But what is iRetry analyzer interface? It is a TestNG provided in TestNG interface, and which will allow us to retry the failed test. So here we can see that we have initialized the maximum retry count up to 2, like it will retry for 2 times. Then we have retry count initialized to 0. Then if the retry count is less than maximum retry count, it will increase the value and it will retry the test. But if not, it will not retry the test. So such mechanisms using retry analyzer or rerun plugin can be used to automatically retry a failed test before marking them as failed. So now let's move on to the demo part. So this is a demo project where I've implemented the adaptive locator recovery algorithm using regular expression heuristic. For this, I have created I've taken a website known as Swag Labs to perform the login functionality. Here we have a login page where we have stored the value of get username locator, and we have three get username locator, get password locator, and get login button locator. These are 3 functions which we will be using to get the value of the elements. Then we have get username field, get password field, and get login button function, where we are calling the find element with self-healing method to find out the element if that element is not if that element or locator is broken. So what is happening in this part is find element with self-healing. It will first try the locating the element using that original locator which was stored in our JSON file. So here I've stored the elements. These are locator key and these are the ID values. of these elements. So in this is a locator library class where functions or methods like get locator, update locator, and save locator are being used. Get locator is basically used to get the locator value of the elements. Update locator will update the new updated value of the locators into the JSON file, and save locator will also save the locator to our file path. In our heuristic utils part, it will first apply the heuristic healing if the element is not found, and it will go to search by regex method, where it will call the create regex pattern. In this method, it will create regular expressions using any of the attributes. It will store those regular expressions in a list. And then what it will do is it will iterate through the regular it will iterate through all the regular expressions one by one in the list, and matches that which regular expression is matching with the elements attribute. Whichever one is gets matched, it returns that element and updates that locator in our JSON file. To view this, let's first add a debugging a breakpoint. Let's say I add a breakpoint over here in the username field, and I'll run my test file where we have set up the Chrome driver, a tear down, and the login function, test login function. If I run it in a debug mode, it stopped the execution. Now let me change the value of the username field manually. I passed the ID value initially in the locators.json file, so I'll change here it to let's say Roy123, and I'll close and I'll just rerun the test. So in the console, we can see that first it attempted to log in, like it printed the statement to attempt the login. Then it attempted to find the element using the original locator for username. But the original locator which I passed in the locators.json file was the ID which was user-name, but I changed it on the UI. So it threw an exception that no such element occurred in that during the runtime. So what it did is it started applying the heuristic healing for the locator key username, which was initially having the value user dash name. And then it called the create regex method to create the regular expressions using different attributes which I had mentioned there: ID, class, name, type, value, placeholder, etc. Now what it did was it matched the pattern of the regular expression with our elements attribute, like it was ID. So it matched it, and it found that with the help of name equal to user dash name, the element gets matched, and it returned that element was found using the regular expression heuristic for the username locator. Say, side by side, it also determined the new locator uh, which was changed on that US. But since like here I have written in the update locator method to return the ID value. So what it did is it returned the ID value which I changed there, and it also updated that value in our JSON file. As we can see, it updated that new value over here, so that when future runs are done, it will use this new value of a username uh, to execute the test. Lastly, since didn't change the values of password and the login button, it printed a statement, and it executed a test without any breakage of failure. Lastly, it printed login attempt completed. So this was the entire demo for the adaptive locator recovery algorithm using regular expressions. So if you have any questions.
So guys, do we have any questions? Anybody? So please don't forget that Nidhi will also be nominating two of you as the Spotlight Nashers. So let us use this opportunity, and we still have time for the session. So we can have a quick round of discussion or question and answers. Anybody, any questions? All right, then, Nidhi, I think we are good to close the session since nobody's asking any questions. It seems like everybody has understood the topic quite well. So, thank you very much, Nidhi, for the wonderful session. And thank you, everyone, for attending the same.
Thank you everyone for joining the session. Thank you, Bharti.